All right, peeps, we're back. So hey, just some stuff over here. Went rather good last time. Trying to move this thing over here. Yeah, get rid of that guy. Yeah, so stuff went pretty good last time, I thought. Generally, people were able to follow the notes, which is good. Um, and then also on top of it, like I think one of the things that made it a little bit more difficult was like just trying to zero in on like some of these over here. Um, so what I'll do is I'll end up reading them off, hopefully, and that might help you out some. We're on to 1.2, systems and models, and I got my notes right here. We're trying that a little different versus reading off a teleprompter. Why systems? Basically, because systems are all about efficiency. When you have a system in place, you can do things more efficiently. I've got a student in class I was talking to about volleyball, and like they had a tough game, and they're just getting housed because they didn't have their systems in place, their efficiency. They didn't really know what to do, or at least the JV didn't. So yeah, guess what happened? The JV took the L, took a big fat loss. Same thing with life and with systems and environments. If you don't have a system in place, there's probably a big mean predator that is going to, eat you, or you are not going to be able to get food, in which case you're going to die. So yeah, that's why systems are important for the environment and just biology in general. Um, Let's see, living or non-living, small or large, tangible or abstract, open or closed, and or isolated. All these are different sort of like systems that they have in place. Um, Tangible just means that like you can touch it. Abstract is something you can't touch as much. Abstract is like physiology. Can you touch your red blood cells? If you can, you're better than me. All right. Open or closed. Open systems have a system that things come in and out of. Closed systems are like, no, it's all self-contained. It's all in that unit. Think about more of like you're in a school building and you've got imagine students come off the bus. They're like put into a classroom. They stay there all day. They even have their lunch brought into them. And then when it's time to leave, like they get on the bus. That tends to be more like a closed system, where schools generally we operate more open system. Um, you have students coming in, students leaving, students going to the bathroom, students going to the principals, students going off wherever, get a drink of water, nurse. All right, students getting picked up. Students are working, students are giving presentations, stuff like that. So isolated systems are ones that are just like completely locked out. I mean, like they're no ins, no outs. It's just kind of like lockdown. Um, so Um, most living systems that we're going to encounter in the environments and stuff are open. Just life has a lot more open systems, like pretty much what we're going to talk about. Um, there are a few closed, like really the Earth is a closed system, but we'll get into that. Materials and energy flows. The way it works out is you're born, you live, you die, and then you become soil again. All right. Doesn't matter if you're a plant. Doesn't matter if you're a human being. Doesn't matter if you are an, Tasmanian devil. All right. That's pretty much all of us. There is like an ebb and flow of it. It's like a circle of life. ESS systems are important. Not studying individual things, but instead how things interact. Think about the lunchroom. We're not studying individual students, but you can start to see like groups of students. These students are trying to sneak out of the lunchroom. These students are trying to like get to lunch first. These students are trying to get out the door so they can go play basketball. Just instead of looking like more individual, just looking at um, the overall groupings of them. How will what I do affect others? With this, like valid for life, especially now. I wish we actually thought about this a little bit more with getting back to a swing of things with just COVID. Um, if you're looking at this, I think like a lot of nationwide, like in the United States anyway, right, with after COVID, there's a lot of fights that broke out in schools and stuff, and I think it was just people forgot like how will what I do affect others, and Yeah, I thought they were, probably during COVID, they just thought life was like a chat room and they could say whatever they want. Um, Environmental decisions are complex because of social, political, economic systems. So, with that, social media. Um, Social media has a big effect on that. Like, for instance, I just got a text from there's a clothing company, Patagonia, and they've been very adamant. They've got one about the Bears' ears. Yeah, let's see if we can get that. Oh yeah, you can read that. Bears' ears update. Days after Utah sued ears boundaries. Bears' ears. So basically, and that's off a text message that I got in a chain. You can go on to Instagram, TikTok, and see a lot of others too. So it's not, environmental decisions are complex because of social um, factors. Also, politics. Like, if you're like in Brazil, we're telling you all to like save the rainforest, but if people need money, if people need jobs, there's that pressure to actually burn down the rainforest, cut down the trees, sell them for lumber, use the land for farming, all that sort of good stuff. So for political, there's always going to be an aspect of political for the environmental systems. Also, too, you got to look good. The politicians, their game is to get reelected, so they're going to do what looks good to you. Make sure that you're actually doing it, though. Don't listen to so much what people say. Look at what they do. Economic systems. Darn right, economic matters for money. Money drives the world. If you don't think it does, I beg to differ. Systems adapt. Deer and bears. So down here, most people think deer live off in the forest. Not so much. Deer will live on the edge of the forest. Why? Because it's a lot easier to come into the farmer's cornfield, eat corn, go back to the forest. Oh, yeah, eat corn in the morning when the humans aren't up. Oh, yeah, and eat corn in the evenings when they go home to the house. Ain't no reason to go out there and see, Joe Brown, the farmer, and, him try to take you out because you're eating his corn. Animals are smart, they adapt. Eat the corn in the morning, in the evenings in the farmer's field. Then they go off to the forest for a little siesta or at nighttime to sleep and for also security. So bears are the same. We have a major problem with bears here in Connecticut. I've heard in New Jersey too. You would think that bears would be way off in New Hampshire and Vermont, but bears tend to go where there is easy food, and where there's easy food is usually humans. They don't eat us, but they tend to eat our trash. So something that bears have adapted to. So systems adapt. All that you can find right in here. This is on page 17. I should have shown you that in the beginning. Why systems right here. This is a Venn diagram right there. Just with consumption, types of systems. We're going to get into that here. Types of systems. Matter plus energy flow. There's three types of systems, really. There's open, there's closed, and there's isolated. So let's take a look at this. With matter and energy, you can't create or destroy it. There's always going to be it. It does change though, and it transfers. So think of yourself. You're matter. You're born. You look different now than the day you were born. You're going to look different when the day you die. And on top of it, when you do die, you're going to break down, go back into the soil, and then that gives room for growth again. So same thing with energy. Energy is not created or destroyed, it is transferred. Sun has the energy, it comes on in, plants absorb it. They take that energy, they then utilize it for photosynthesis. That energy is then transferred on off to the animal that eats the plant. So, transfers, a little change in state. So, in the state, they mean like, are you a liquid, a solid, vapor, magma. That's what they mean by state. They don't mean state like state of the Connecticut or Massachusetts or New York State. So transfers happen more just like with plant and human growth. They're um, they're not big transformations. It could be the difference in how you look one day versus the next, 1 year versus the next. Now, transformations are tend to be bigger changes. Think of a fire. You have a piece of wood, all right? You put that wood into a fire pit. You ignite it. What you have is that wood then transfers or transforms from wood into light, into heat, into smoke. Yeah, and also into fire. So that's that transformation. It's changing physically. Both require energy, but transformations require more energy. There's also more energy lost in transformations. Down here, open systems. They're non-contained. So open systems, they're just they're an environment. They're a school building. Things ebb, things flow, things come in, things come out. Most systems and all ecosystems, all the ecosystems we talk about, they're all open. Plants fix or lock up energy, light into photosynthesis. So light comes in, the plant takes it, and it in the leaves and uses photosynthesis. Plant grows. As it grows, the animal comes in, eats the plant. The energy is then transferred off to the animal, and then the animal might get eaten by a bigger animal, and then the biggest animal eventually dies, and it goes back into the soil with the energy. So, soil bacteria fix nitrogen from the air. Healthy soil has nitrogen in it. Uh, It, has bacteria in it. The bacteria basically takes the nitrogen out from the air. Herbivores eat in the fields, then poop in the forest. Yep, open system. We talked about that with the bears and with the deer. Forest fires expose topsoil. Wind, rain takes it away. So something from the outside comes in, takes it out. Open system. Water evaporates in transpiration from plants. So water, you have transpiration. It's basically where it's just sweating away. Heat is transferred. Animals give off heat. Think of the kid next to you in class. Especially if he's got body odor. That didn't get there by being cold. Our bodies produce heat. Try learning in an environment that's pretty hot. It's pretty tough. So, closed systems. Closed systems exchange energy but not matter with the environment. I'm going to go up to this one again for a second. Minerals leach from the soil to water. Also, think about that with fertilizer. When you're applying fertilizer onto a field, it doesn't just stay on the field, it leaches on off into the rivers. The rivers then carry it out to the ocean, and that's where the fertilizer is. Would that have a problem if you're spraying insecticides and fertilizer? Think of it. Would that fertilizer that goes off in the ocean, would it help promote algae or seaweed? Would insecticides have an effect on lobsters? Oh, yeah, by the way, lobsters, the name for lobster boats, the nickname for them is bug boats. So, just different things to think about. Let's get back down to this. So, closed systems exchange energy but not matter with the environment. They tend to be rare in nature. Hydrological carbon nitrogen cycles are all closed. So, the hydrological system, that's with water. Water isn't really made or destroyed in the earth. It's a cycle. So a lot of our water is locked up in glaciers, but as glaciers melt, that then runs on off into a river. That river runs on off into the ocean. The ocean has a storm that comes along. It basically sucks up the water into a cloud. The then cloud runs over land, and then it just dumps down that rain, which then goes back into the river, back to the ocean, and it's one big cycle. Or with snow, it's instead of rain, you're going to have it hit land and settle there as snow, and it will slowly drip into the rivers and actually into the land. And snow is really good for farmland because of that. The water just doesn't wash away into the river. It really gets the water table for land up higher. Carbon. Talked about life. You're born, you live, you die. Carbon cycle. Doesn't matter if you're a plant or human. Oh yeah, and that when you die, it goes back into the soil. Nitrogen cycles, same deal. Closed system would be Earth. It's really the only one I can really think about. Maybe you could talk about how you were a closed system if during COVID, during lockdown, if you were just in your bedroom. You could debate me on that, but that's an interesting one. Isolated systems don't exchange matter or energy. Does not exist naturally. A isolated system has no in and no out. Everything is contained inside. So that's something to think about. All right, so we're gonna get to some stuff you're gonna have to look up here. I'm gonna try reading this off for you. Look up on YouTube, Jane Pointner. Sorry, peeps, I just messed that up. Come on, soar. I thought we talked about this. Do better. All right, forget this. I'm just gonna go down. All right, this first one right here. Look up on YouTube. TED Talk Jane Pointner. Watch any of the 15-minute videos. It's got to be a TED Talk about Jane Pointner. All right. Why was it called Biosphere 2? Why do you think Biosphere 2 a closed system? List a few land-based and seawater-based ecosystems found on Biosphere 2. If you had to run this school as Biosphere 3, which 8 people are you choosing from the school and why? Think of it as Biosphere 3 draft. So, not sure you want to pick me for that one. I'd sell out. Here's some disgusting thoughts on open closed systems. Are you drinking someone else's pee? All right. Remember, with matter, at some point, if you're talking about water, it went in somebody's body and it went out. When you eat French fries, are you eating a dead relative? Your relative died. That matter, that body became matter that decomposed into soil. That soil gave birth to plants, in this case, a potato. That potato got cut, entered a fryer, then opened your mouth, and went in there. Are you eating a dead relative? Look at page 24, the Venn diagram. I'm sorry, I haven't been following this book much. But on page 24, derp, right here. So sustainability is right here in the center. Economic, social, and environmental. Say there's land, all right, local. You want to set it aside for a park. Economically, is that doable? Can your town afford to do that? Can it afford to lose the tax revenue? Environmental. Will that park be good for the environment? A lot of the things we thought are good for the environment don't always end up being. If that park is introducing invasive species, yikes, no good, no buenos. Social down here. Is it good socially for the society, or does society need another baseball field, another shopping plaza, another gas station? All valid. So that's looking at page 24. I want to talk a little bit about models here. Models take many forms. We're going to talk about the positive. Models can be acting. Okay, models can be even really what I'm doing with my hands, where I'm like talking with my hands. Models are easy to work with. Models help out visual learners. They can predict effects. So the weather report, when you watch the weather, that's a model. Can apply to other sims as well, or simulations. Can visualize large and small things. So if I was to explain to you how your digestive tract worked, using a model would actually help out quite a bit, because it breaks down the physiology, the small things, and then makes them bigger for our eyes to see and comprehend. Negatives, which all these are positives, the negatives are this. Accuracy is lost. So when you break things down simple, a lot of the details get lost. If assumptions are wrong, the model is wrong. That simple. Predictions not always accurate. So this is a short one. This is 1-2. This will bring us to page 26. So thanks for following along. And yeah, let's get ready. Do awesome. Bye.